We are pretty lucky that our planet is a solid terrestrial planet. If we were born on a gas giant instead, chances are that we wouldn't be able to survive. But what if we somehow managed to live on a gas giant? How would life be like? Do we even be able to walk? Welcome to Life Nogging. Today, we're going to find out what would happen if we lived on a gas giant. Jupiter is the largest planet in the solar system, so we'll use it as our example. Gas giant. Jupiter is 318 times the mass of Earth, but only 1/10 as dense. It has more than twice the Earth's gravity, but its atmosphere is mostly hydrogen and helium with traces of methane, ammonia, and water vapor. Since Jupiter doesn't have a solid surface, we need to build our homes in the atmosphere. This would mean that we'd need some sort of airship or flying home. We could use airships similar to balloons to float above Jupiter's surface. These airships would need to be filled with a substance lighter than hydrogen, which isn't easy. One option would be helium, but that's not very abundant on Earth. Another option would be some sort of synthetic gas lighter than hydrogen. Lighter gases expand more for a given amount of pressure, so they would float higher up in Jupiter's atmosphere, where the pressure is lower. Another option would be to create a flying home that uses anti-gravity or negative gravity. Anti-gravity is a hypothetical form of energy that would counteract gravity and allow objects to levitate or fly. In the anime series Full Metal Alchemist, Edward Elric and his friends live in a flying airship powered by alchemy and anti-gravity. In the show, anti-gravity is created by using alchemy to convert one type of matter into another type of matter with a different density. The resulting difference in gravitational potential energy between the two types of matter creates an explosive release of anti-gravity. If this is just science fiction, there may be ways to create something similar in real life. One way would be to use the Casimir effect. The Casimir effect is a physical phenomenon in which a vacuum can exert a force on objects placed within it. This force arises from fluctuations in the quantum vacuum, which can cause objects to be pushed together. The Casimir effect has been observed experimentally, and it is used in some modern technologies, such as nano-electromeshnal systems, by using a device called a Casimir piston. We may be able to create a force equal to anti-gravity and use it to keep our flying homes aloft above Jupiter. If we can create a suitable flying home, then getting around on Jupiter should be pretty easy. With enough propulsion, we could get anywhere we want on Jupiter in no time. Plus, since we'd be above most of Jupiter's clouds, we'd have amazing views all around us. And depending on how fast we traveled, we might even be able to see the other Galilean moons of Jupiter: Io, Europa, Ganymede, and Callisto. On the downside though, traveling on Jupiter would be dangerous. Jupiter has powerful winds reaching speeds of over 600 miles per hour. That's fast enough to blow our flying homes away or smash them into each other. And while we're inside our flying homes, we'd have to watch out for lightning. On the plus side, at least it would be light enough for us to go outside and take a stroll. Here on Earth, atmospheric pressure depends on the weight of the air above us. Since Jupiter's atmosphere is much more massive than Earth's, the pressure at ground level would be about 100 times that of Earth. At that pressure, we could easily crush a human skull like a soda can. However, we could avoid all this crushing pressure if we built our flying homes high enough off the surface. In fact, we could probably live comfortably on Jupiter if we floated high enough, at about 500 miles above Jupiter's surface. The atmospheric pressure would be roughly equivalent to Earth's pressure at sea level. The temperature at this altitude would also be comfortable, ranging from 200 to 400 degrees Fahrenheit. There would be plenty of room for us to build our homes at this altitude too, since Jupiter's atmosphere extends hundreds of miles above the surface. Fortunately, we'd need to stay within a small range of altitudes. If we went any higher, the atmospheric pressure would become too low for humans to breathe. Luckily, we wouldn't have to worry about being too high above Jupiter's surface. Since there's no solid surface on Jupiter, the sky really is the limit. As long as we didn't run into any storms, floating above Jupiter would be peaceful and serene. Of course, we'd have to watch out for Jupiter's iconic Great Red Spot, a massive storm rising high above Jupiter's surface. The Great Red Spot is a high-pressure storm that has been raging on Jupiter for centuries. To calm above the Great Red Spot would be nice though, since that's where we'd want to go to do some cloud surfing. Cloud surfing is a real activity on Earth, although it's only possible when the conditions are just right. To go cloud surfing, you would essentially sit on top of a large cloud and let the wind carry you along. As the cloud moves through the air, it rises and falls, creating a wave-like motion that you can surf. Since Jupiter's atmosphere is mostly hydrogen and helium, we shouldn't expect to see clouds made of water like we do on Earth. Instead, it would likely be clouds made of solid particles of ammonia, ammonium hydride, and other compounds. These particles would be formed by the condensation of gases in Jupiter's atmosphere as it cools at high altitudes. We could also see clouds of hydrocarbons, which are compounds made of hydrogen and carbon. These clouds would form in the upper atmosphere where temperatures are extremely cold. Once we got tired of cloud surfing, we could go down a little to watch the jet streams. Jupiter's jet streams are even more extreme than Earth's. They reach speeds of over 400 miles per hour, and they've been around for hundreds of years. Watching these storms would be breathtaking, but we wouldn't want to get too close. If we were unlucky enough to fall into one of Jupiter's storms, we'd be met with unimaginable violence. The winds would rip our flying homes apart and throw us into the colossal depths of Jupiter. Falling through Jupiter's atmosphere would be like falling through a black hole. Eventually, we would hit the liquid metallic hydrogen layer of Jupiter, where the pressure and temperature would be thousands of times that of Earth's core. Here, we would be met with unimaginable heat and pressure, and we would be completely crushed and vaporized. So we would definitely want to stay far away from Jupiter storms. Even though Jupiter is massive, it doesn't have a solid surface. So we wouldn't be able to build a colony on it like we could on a terrestrial planet. We could make a base somewhere in Jupiter's atmosphere, but we need to be careful not to get blown away in a storm. We'd also need to find a way to generate power on Jupiter. On Earth, we use nuclear fission to generate power, but we couldn't do that on Jupiter because it would contaminate Jupiter's atmosphere. We could also harness the power of Jupiter storms to create clean energy, but that would be incredibly difficult and dangerous. Luckily, we may be able to use the pressure and temperature of Jupiter's atmosphere to generate power. For example, we could use a device called a pyroelectric generator. A pyroelectric generator is a device that converts heat energy into electrical energy. The device consists of a crystal of a special material that generates electricity when it is heated. We could place a pyroelectric generator in Jupiter's upper atmosphere, where the temperature is around 400 degrees Fahrenheit. The heat from the atmosphere would generate electricity that we could use to power our flying homes and colony. While living on Jupiter would be exciting, it would also be incredibly dangerous. We'd have to constantly watch out for storms and other atmospheric phenomena that could destroy our flying homes. Plus, there's no guarantee that we could even survive on Jupiter in the first place. On the other hand, living on Jupiter would also be an incredible adventure. We'd get to experience some of the most extreme weather phenomena in the solar system, and we'd get to explore a new world unlike anything we've ever seen before. Jupiter is a gas giant with a massive atmosphere, so we wouldn't be able to walk on it. We could, however, build a base somewhere in its atmosphere and use the pressure and temperature to generate power. Jupiter has powerful storms that we could use to generate clean energy, but it also has extreme cold and darkness in its lower atmosphere. We could use devices like the pyroelectric generator to convert heat energy into electrical energy. Living on Jupiter would be dangerous, but it would also be an incredible adventure. So, what do you think? Would you want to live on a gas giant like Jupiter? Let us know in the comments section below. As always, it's me. This has been Life Noggin. Don't forget to keep on thinking.